ChatGPT is a conversational AI model developed by OpenAI, which is trained on a large corpus of text data from the internet to generate human-like responses to user inputs. This model uses a variant of the transformer architecture, which is a deep learning approach for natural language processing. In this article, we will delve into the details of how ChatGPT works and its underlying components. At its core, ChatGPT is a language generation model that is trained to predict the next word in a sentence given the context of the preceding words. To do this, the model takes in a sequence of words, the context, and outputs a probability distribution over the vocabulary for the next word. This process is repeated until the model generates an end-of-sentence token, indicating the end of the response. The architecture of ChatGPT is based on the transformer architecture, which was introduced in 2017 by Vaswani et al. In their paper "Attention is All You Need." The transformer architecture is a type of neural network that is designed specifically for processing sequences of data, such as text. The key advantage of the transformer architecture is its ability to handle long-range dependencies in the input sequence, which allows it to better capture the meaning and context of the input. The transformer architecture consists of two main components, the encoder and the decoder. The encoder is responsible for encoding the input sequence into a fixed-length representation, which is then passed to the decoder. The decoder then uses this representation to generate the output sequence. In the case of ChatGPT, the input sequence is the context, and the output sequence is the response. The encoder in ChatGPT consists of a stack of identical layers, each of which contains two sublayers, a multi-head self-attention mechanism and a feed-forward neural network. The self-attention mechanism allows the model to attend to different parts of the input sequence and weigh the importance of each part in the encoding process. This allows the model to better capture the meaning and context of the input. The decoder in ChatGPT is similar to the encoder, but with one important difference: it also has an additional multi-head attention mechanism that attends to the encoded representation from the encoder. This mechanism allows the decoder to attend to the encoded representation and generate the output sequence based on this context. To generate a response, the model starts with an initial context, such as a prompt or a partial response, and then repeatedly generates the next word in the response until it generates an end-of-sentence token. At each step, the model takes in the current context and generates a probability distribution over the vocabulary for the next word. The word with the highest probability is then selected and added to the context, and the process is repeated until an end-of-sentence token is generated. One of the key challenges in building a conversational AI model is ensuring that the model generates diverse and coherent responses. To address this challenge, OpenAI introduced a number of techniques in ChatGPT, such as top-K sampling, nucleus sampling, and beam search, to ensure that the model generates diverse and coherent responses. Top-K sampling is a technique where the model generates a probability distribution over the vocabulary for the next word, and then selects the K most likely words. The model then selects the next word from these K words, rather than selecting the word with the highest probability. This helps to reduce the risk of the model always selecting the same word and generates more diverse responses.